film number 2 about reliability, and this is about mean time between failures. We will also look at topics like mean time to failure, mean downtime, mean uptime, and reliability. If we have a system like this shown in the figure here, you have uptime and downtime. Uptime means that the system is working according to specifications, and downtime means that we can't use the system. So obviously you have downtime before you turn it on. You're not using the system. Then you turn it on and it works for a given amount of time before a failure kicks in. So failure number 1, you have downtime because it's not working, and then you fix it and you get a new uptime until it fails again, and it goes on. So the mean time between failures is the MTBF is the estimated time between self-caused errors in a system. It's not the errors caused by the operator. So for example, in the case of a car, if you use the car and it suddenly fails, like if the steering wheel fails or the brakes fail, then you definitely get downtime. Let's say that the steering wheel fails. But if you run the car and you collide with something, or you drive it off the road or something, that's a self-caused failure, which is not a part of the statistics here. The statistics is the reliability of the system, not the reliability of the driver. So the MTBF is an abbreviation for mean time between failures. So it's defined as the total time monitored systems have been available. So if you have 100 systems, we monitor them over a given time and we write down how long they've been available, and then divide it by the number of failures, and that would give us the mean time it took between the failures. So here it's the MTBF is actually the average length of those 3 arrows there. That's the MTBF, and that's actually the inverse of the failure rate lambda, because the failure rate lambda was defined as the number of failures over the time monitored. So that's the inverse. MDT is mean downtime. It's a measure for how long it usually takes to repair and restart the system. So you have the average length of the down arrows here. Actually not that one, the other ones, the one that where we spend time repairing the system, that's when we use the MDT abbreviation. Mean time to failures, that is for systems that are not repairable, is the same definition, is the total time monitored over the number of failures. It's still 1 over the failure rate lambda, but it's used for example, a balloon or a light bulb or something that will not be repaired. However, a system like a car may be made up by elements with MTTF, like for example the windscreen or something. You will not repair a broken windscreen, you will change it for a new one. And MTBF for systems that will be repaired, like for example the entire engine or the entire car as a system. So mean time to failure and mean time between failures are basically the same thing, but for one is for systems that are repaired, and one is for systems that will not be repaired. Here's an example, and I just made up the example with a TIDE bus company, and it's the company in Bergen that run all the buses here, so it's called TIDE. It means timely or something like that in English. Let's say, and this is a totally made up example, let's say that I have 500 buses and they are used 24/7, so they are running all the time, and they've been running for exactly 5 years. During that period, there have been 1,200 unplanned self-caused failures, which meant that the bus was out of service. And on average, they were in service again after 4 hours. So what would be the mean downtime? Well, the mean downtime, that's easy, because it's given from the text. The average time it was in service was for 4 hours, so that's actually the mean downtime, 4 hours. Was the total time monitored? Well, we have monitored it for 5 years, exactly. But then we have 1,200 buses. No, sorry, 500 buses. And 500 buses monitored for 5 years. That gives us a lot of experience. Since they fail a lot, we can mirror image the logo here and get what kind of buses they are. Mean downtime given from text 4 hours. Total time monitored 5 years, 365 days a year, 5 buses. So we have monitored for 913,000 days. The total downtime would be the number of failures multiplied by the mean downtime, right? 4 hours on average, and we have 1,200 failures, so that would be actually 200 days of downtime over those 5 years. Total uptime, it's the total time monitored minus the downtime. So when it's not down, it's up, so it would be 912,000 days. And mean time between failures would be the total uptime divided by the number of failures. So it's 761 days on average. So for each bus, you can assume that the bus would run for 761 days before it failed. But then again, it would be a self-caused, unplanned failure. During that the period of 761 days, I would assume that the buses would be in for service and check the oil status, check the tire status, check the windscreen wiper status, and so on, and replace those components that were worn out. This is the unplanned failures, like the handbrake suddenly failing, or maybe a cylinder in the engine failing, or I don't know what. But unplanned failures, not the ones that are fixed during service, which is planned downtime. So it's unplanned downtime we're talking about.